And welcome, students. As we continue our evaluation of Boolean expressions, let's actually evaluate now those Boolean expressions that we've been talking so much about. So getting started, Boolean expressions, of course, if you remember, are used to evaluate conditional branches, and also they can be used to evaluate in loops. So recall a Boolean returns simply true or false, and a Boolean variable can store this value of true or false. So for example, Boolean meta equals time is less than limit, and limit is less than max. So let's look at some operations, therefore, that we can do to Booleans. A Boolean expression can be evaluated similar to how we evaluate an arithmetic operation. So instead of using plus, minus, divide, multiply, we'll use relational operators such as equals, less than, greater than, and Boolean operators such as and, or, and not. Now the output of a Boolean operation is always going to be simply true or false. There's no other outcome. So it kind of makes it pretty nice in that regard that we know it's always just one of two things. Now let's take a quick comparison of an arithmetic expression versus that of the Boolean. So a quick example here, number plus 1 times number plus 3. If you assume number has the value of 2, let's go ahead and evaluate this. So to evaluate this, we're going to evaluate the sums. So I'm going to get 3 times 5. Next, we combine using the operator of multiplication to get 15. Now the code didn't multiply the expression so much as rather the values of the expressions. Now a Boolean works pretty much the same way. So to obtain the values that are either true or false. And the way that we can do this is by using something known as a truth table. So here is the and truth table. I have two expressions. I have expression 1 and expression 2. And you can see that it's set up as true, true, false, false, and expression 2 is set up as true, false, true, false. All right, so that's pretty much sets up every 4 conditions that you can make with a and expression. So this says expression 1, expression 2. So if they're both true, the outcome has to be true. If one is true and one is false, the expression is false. If it's false and true, the answer is false. And if they're both false, the answer is false. That's the nice thing about and. So you know it can only be true if both expressions individually are true. Now, if we look at an or truth table, we can see very similar things. We have our two expressions. We have true, true, false, false, true, false, true, false. And here is our actual evaluation. So when we have true and true, it's true. True, false, it's true. False, true, it's true. And false, false is false. So just like as we've talked about in the past, with an or, it's always going to be true unless both conditions are false. So the only way you can get a false in an or is for both of the conditions to be rendered as false. Now when we look at a not, all that simply does is simply flip the states. So if the expression was true, it makes it false. If the expression was false, it makes it true. So let's use some truth tables in order to do some evaluation. So let's consider the expression. Here we have not, count is less than 3, or count is greater than 7. So the program will evaluate from the inside-most parentheses first. So let's set count equal to 8. All right, so is 8 less than 3? Well, that's false. Is 8 greater than 7? That's true. All right, the false is because 8 is not less than 3, and the true is because 8 is greater than 7. The program then evaluates the next step. True. All right, according to our truth table, false and true is true. All right, the program now is going to evaluate the not function, providing a final answer of false. All right, now let's look at how we can use those Boolean variables in actual assignments. A Boolean variable can be assigned the value of a Boolean expression by using an assignment statement. So here's our example. Int number equals -2. Boolean is positive is equal to number is greater than 0. This example tests to see if a number is positive and then stores the Boolean value of true, false, and is positive. Let's use our Boolean example now from the previous page to be used in code like any other variable. Boolean is positive equals number is greater than 0. If is positive, system.println, number is positive. Else, system.println, the number is negative or 0. So this is a quick way to use this. Now, of course, you can still, of course, have code this in here, number is greater than 0. But this is just a quick and easy example of showing you how you can use a Boolean within the code here. This is, again, a very basic example. All right, as I mentioned, it could be done without a Boolean, but the structure and the idea that we're trying to convey here are very much the same. Now, I have a quick warning for you about using true, false. In many programming languages, 1 is used to represent true, and 0 is used to represent false, pretty much because 1 was the on, or the high voltage state, and 0 is the off or the low voltage state. Languages such as C++ automatically will convert Booleans to integers and vice versa when the context requires it. Java, though, does not define true false as numbers. It doesn't have any numeric equivalency, nor can you typecast them to a numeric type such as int or vice versa. I mean, there are some ways you could try to finagle it, but it is not the way they're built into Java. All right, naming Boolean variables. Now, in order to help differentiate Booleans from other primitive types, create your Boolean to be a statement that will be true when the Boolean is true. So, for example, is positive. Pressure okay. Those could be examples of statements that when they're true, it's true in its name. So, hey, is it a positive number? Yes, it's positive. Is the pressure okay? Yes, the pressure is okay. All right, and that's going to wrap up the notes, folks. So hopefully they give you a little bit of idea of how we're going to evaluate Boolean expressions. And next time I'm going to give you, rather than having to go through a whole truth table, we're going to look at some short circuit ways in order to make it simpler. Until then.